This is the exact value I calculated, exactly half of 5 volts. I should be able to use that for my LED. Now the LED turns on, but my voltage has collapsed. The voltage didn't disappear. The red LED can use this voltage, and once it stops conducting, it pulls current from the divider. Let's try a different colored LED. Switching in my white LED, no matter which way I orient it, nothing happens. My voltage doesn't collapse, the LED just never turns on. However, this doesn't mean that nothing has happened, it just means that this LED needs a lot more voltage than this node can provide. Unlike the red LED, the white LED needs a lot more forward voltage to turn on, but it doesn't collapse the voltage. Moving back to our red LED, let's try to figure out what our problem is. We can see that our LED is turning on, but it's flickering and a bit dim. Measuring our voltage, we see 1.8. If we were to remove the load, suddenly we get all of our voltage back to 2.5. Why is using the voltage causing the voltage to drop so much? The problem isn't the LED. The problem is this divider was never meant to power anything. Let me explain. This exact problem shows up everywhere, so instead of asking the divider to do more, we can isolate it. That's why they invented this chip. This is the LM358. It's an op-amp. But we're not using this to amplify anything, we're going to use it to not interfere with the voltage. Let's place our op-amp onto the board. Pin 4 is our ground pin. Pin 8 is our voltage in pin. Pin number 3 will be the midpoint for our voltage divider. So I'll take my two 10k ohm resistors, one coming into the power rail and one coming into the ground rail, both coming into pin number 3. I'm going to want to connect pins 1 and 2 together for feedback, and pin number 1 is going to be the outfeed into our LED. Our same 470 ohm resistor, and then we connect our LED back, and we can see our LED immediately is a lot brighter. Now let's see how our voltage looks. Oh, 2.43, and it's a lot more stable than it was previously. It's not flickering, the light doesn't flicker, it doesn't even waver. Now the divider creates the voltage and the op-amp protects it. So instead of having it flicker, it stays stable. However, that doesn't mean the LM358 is always the right choice. It does have its limits, and choosing the right buffer depends on the voltage range, speed, and noise. Now, voltage never technically disappears. They just collapse when the circuit that creates them can't support the load. Buffering is how we separate sensing from doing.